But this time, one of your colleagues looks at you and they say, this week I deleted code. The system still works, but there is less code. This is magical, right? Everybody is in shock. Now the code is elegant. Now the code is organized. Now the code is clean, and we are all leaving the weekly meeting, boom, saluting each other. We are the best team out there. Everybody is happy. Because what feels better than taking a huge chunk of code and just removing it from our code base? What feels better than taking 4 lines of code and converting them into one? That's right, I'm a spy. I converted from Java to Python, and I'm not looking back. So I thought about this, and then I told Dan, you know what? Okay, I understand what you mean. I understand your needs. We will take care of the code. We will fix our technical debt. We will take a sprint. We will regroup, organize, and then we will go back to writing new features. We were very happy with this arrangement. And while we were working, we were thinking, hey, you know what? This is pretty interesting. How did we even get to this state that one of us says, listen, we need to delete everything. Everything must go. And we were talking about it, and we said, you know, code is basically like organic matter, something organic. The moment it's out there, the moment it's fresh out of our keyboard, it starts to rot. Even if we don't do anything, right? Even if we just leave it out there, it's the best code, no matter like the time. You just finished writing code and it immediately starts to rot. In a few weeks, maybe in a few years, it will be outdated, it will not work properly. So we have to continue taking care of it. Which means that the moment we finish writing code today, our life splits into 2, right? We have to write new code. There's always demands from clients or product managers or these guys, you know. And there's also the need to take care of our existing code and make sure that it's clean and nice. And we have to do both. And usually when I show this slide, people tell me, yeah, this is nice. This is very nice theory. But in my company, this is what it looks like. Nobody really likes to fix technical debt. We don't like to do it. It's much more fun to write new features. This is what we are in for. And I understand. But if we go back to the bicycle metaphor, these are like the 2 pedals that keeps us moving forward faster. So whenever we are writing software, if we want to continue faster, we need to make sure we are doing both things. I was pretty happy when I understood this. It really affected how we build software in our company. And I said, Dan, you know what? Maybe we should sit and think, what are other things that we can do to improve our coding? We want to improve the software in our company. What should we do? We came up with nothing. And then Dan told me, Jonathan, I have an idea. So I think you start to understand what it's like to work with this guy. And he tells me, listen, we should make a web series. We should go out to some of the biggest companies, talk with their R&D leaders, talk with these people because they know how to build software. Eventually they got to these ranks. They know what they are doing. Let's understand from them how to build software better. I told him, Dan, this is an amazing idea. 2 guys talking about technology. Who has heard about this? This is super new. The world needs more of this type of content. And Dan says, okay, I understand what you mean. I understand what you mean. This is great. Let me go home and think about it. 3 days pass, and I get a phone call, and he tells me, Jonathan, no, I'm kidding. He doesn't tell me this again. But he tells me, listen, Jonathan, I talked with these companies, AI21 Labs. They are developing models that actually compete with GPT and OpenAI. Wix, which you've heard a talk from them yesterday, and Tori, 3 technological giants. I talked with them. They are in. They want to do the TV show. Let's make a web series. I said, Dan, this is fantastic. This is great. Let's do it. The only issue is that I have no clue how to make a web series. I never made it. I'm great at watching them. Though, don't get me wrong. I love watching web series. But producing, different game. So lucky for me and for you, in case you want to do this sometime, making a web series is very easy. It's like making a cake, okay? And stay with me because the photos I know that they are distracting. So to make a cake or a web series, there are 3 things you need to keep in mind. First thing, the format, right? You cannot make brownie in this type of dish, and if you do, throw it away. It's not a brownie. So we need to think about the format of our web series. What does every episode look like? What are we going to talk about? Who are we going to talk about? Etc. Second thing we need to notice, ingredients. In the case of web series about development, the ingredients are the speakers, right? We want to make sure that we have good speakers that understand what they are talking about, that understand the field, that understand software. This is what we need. So we went and got these people. And third thing, and this is maybe the most important thing, because, yeah, sure, cakes are sweet. Sweet is good, everybody likes. But what makes a cake truly great? What makes a dessert truly stand out? The answer is a game of flavors and textures. Because if you think about it, what makes a cheesecake really great is just these small pieces of fruit. It's the layers of chocolate between the sponge cake. It's also these tiny pieces of orange and rose cream. I love this. I tried this yesterday for the first time. Amazing. Loved it. So we understand, okay, we are going to make a documentary about software development, but we need to spice it up. We need to put some humoristic bits inside to make it a bit more captivating, a bit more entertaining, etc. And this is what we did. We went out, and we started interviewing these people. How did we do it? What did we talk with them about? We talked about everything the developers love and everything the developers hate. We talked about GUI versus CLI, front-end versus back-end, and some more serious stuff, like the imposter syndrome and how to deal with it. We went to multiple companies, and we asked them the same questions. We asked them, how do they deal with dead code? How do they deal with technical debt? What are they doing to improve their standards in their company? We then took every subject, and in a kind of like in a slice, every episode is dealing with only one subject, and this is the episode where you learn about what you can do to improve software in your company. Eventually, we finished with a web series with some of the largest companies in tech. Really interesting, it's out on air, and we learned a lot from it, obviously, and this is what I want to share with you today. So I'm going to share a few lessons on the state of software and what you can do to improve, and then we will, as I said, we will jump a bit forward. So I think one of the things to begin with when we start with this TV show is just to understand what type of data do we have. So we interviewed these 8 companies, more than 60 hours of interviews, more than 28 engineers. These are the logos. And we took all of the text, we transcribed all these interviews, we went down and started marking, what bothers people, what bothers developers. Every time somebody said in an interview, this bothers me, this is bad, this is not so ideal, we marked this down and we try to narrow it down to what affects our developer experience. So I'm sure you've heard the term developer experience. It's not about ping pong and beers at the office. It's actually more than that. So I think before we dive into the lessons, we should define it between ourselves. A good definition for developer experience that is not the cute stuff at the office is very similar to user experience. Right? So when a user, for example, wants to order a pizza, how much friction do they have between the moment they decide, I want a pizza, and the moment they have a pizza in their mouth? Do they need to activate 3 apps? Do they need to make API calls for some reason? What are they doing in order to achieve their goal? And as developers, we also have goals, and we are also doing some things to achieve them. And we face friction. So developer experience is kind of like the measure of friction that we have between our desires and our goals. So looking at all these interviews that we made, we identified about 81 blockers. 81 things that stop us from having a good time at the office, let's say. Or 81 things that add friction to our job. So I'm now going to review them one by one. No, I'm kidding. I'm going to share 5 main lessons that deal with the majority of these things. And I would like to remind you that this was a 1.5 years ago, so this was before you went into any room and all you could hear was ChatGPT, AI, LLM. It was mostly about what we actually do in our work, how we work, okay? The first lesson, and I think maybe the most important one, is that specifications matter. Right? The happiest teams, the happiest software teams were those who knew what they are doing. When they approached a task, they had it laid out to them. Imagine you are opening a pizza ordering app. Let's return to this motive. And the app just, there is no clear structure. You can go from any screen to any screen. At any point, you can do whatever you want. It's a complete mess, right? We like it when things are structured for us, when we have our solutions laid out for us. And it also helps the team understand what are we working on, make sure we are aligned, etc. This will come back when we talk about the future, actually. So this is one important lesson. If you are not using the practice of writing specs, I recommend starting. It's really helpful, and a lot of developers report that it actually improves their life. Okay, second lesson out of 5. the tooling paradox. So I took this picture. It's a tiny picture out of the CNCF available tools for developers. We have so many tools. Look at it. This is impossible to even, for one person to understand all of these tools. What are they used for? What are they good for? When should I use each one of them? And I understand, okay, because we are developers. So we see 15 frameworks, and we immediately say, we need a 16th framework that unifies all the previous frameworks. This is how we work. This is us. But actually, it makes our job much, much harder. So even though companies that, they were very open to applying new tools and using new tools and buying new tools for their workers, this is on one hand, this is great. On the other hand, we see that companies with over-tooling actually make their developers' life harder because getting into a task requires much more knowledge than you would require at another place. So keep your tools to a standard level. Don't over-tool. Third lesson, coupling is frustration. I think this is very clear, but just to make the point extra strong, imagine that every time you wanted to order a pizza, you had to call your personal trainer, and he had to approve it for you. So I'm not sure, but in my case, he would never approve it for me all the times I want to order pizza. But we want to decouple as much as possible. We want teams and developers to be independent, to be able to carry a task from end to end. We don't want them to depend on someone and have them wait for that person to return and tell them what to do, etc. And in direct relation to this, we have lesson 4, which is knowledge sharing. Knowledge sharing and frustration and coupling is very much hand in hand, right? And knowledge sharing, let me tell you, this was the one thing that everybody agreed on from the interviews. Everybody agreed that better knowledge sharing means better software, which is pretty interesting because on the surface level, if you share knowledge, it doesn't necessarily mean that the code you write would be better, that the software would be better, but in practice, these are the results. And finally, continuous feedback. You ordered your pizza, you got the pizza. How would you know how to improve? How would the network of pizzas know how to improve? They need to get your feedback to understand maybe the dough was not okay, maybe the cheese was too old, I don't know, whatever you put on your pizza. But they need to get the feedback. So continuous feedback, internal continuous feedback, really keeps the company going, really improves us as a team, and improves our software. Okay. So these are 5 lessons about software today. And I think when you look at these lessons and you are wondering, are these problems going to continue with us forever? Because when people wrote software in the early 2000s, it was also evident, right? People still needed to share knowledge. There was still coupling. They still needed to do specifications. There were still tools, maybe less, but there were still a lot of tools. And they also had to collect feedback. So is this something that is going to go with software development forever? And now I want us to make a small switch and start talking about the future of software and where we are going in a few years. What is going to change and how we are going to apply AI to solve most of these, and how will our days and day-to-day look like. So the first thing that we need to say, and I think this is important in every software conference, is that we still have a job for now. I'm not saying that software developers are going anywhere, right? Maybe our profession will change. The things we do on the day-to-day definitely will change. But we are not going anywhere. I remember that about a year ago, my mother, she's 70 right now, she heard on the news that ChatGPT or whatever can now write code. She called me, she was super panicky. She was like, Jonathan, I understand that your job is at risk, that now these AI models, they can write code. I told her, yes, that's true. There was silence, and she told me, I knew it, you should have been a doctor. But that's for another talk. We still have a job. We are not going anywhere, even though these models can write code. I'm sure you all experienced the code they write. Not ideal. Sometimes there are bugs. Sometimes there are issues, even though they always say it with grace. They always say, here is the code you wanted, but it doesn't work. So we still have a job, and also it's important to say that I do not expect it to change anytime soon because there's still demand for software. We still need to solve real-world problems. People need to ship containers from China to India and from India to the States, and we need software to manage that. And the more we grow, the more we advance, we need more software to help us manage other issues that we are facing in real life. This change will not happen in an instant. We will not be out of jobs in the next few years. We will definitely change. So what is going to change? There are two changes that are carried out every time there is a big change or a big earthquake in the software world, and dare I say, in other fields as well. One of these changes is new skills. So if you remember when we moved to the cloud, when people started moving to cloud development, a lot of developers had to learn new skills. For example, communicating with your DevOps person, very important skill. So in the same way, now that AI is coming into our lives, we would also need to learn new skills for writing software. And to understand what skills exactly, let's look at our pyramid of time. So on the left, you can see the pyramid of time of software developers. These days, code-oriented development, it's what we are doing today. We spend the majority of our time writing code. This is the thickest layer at the bottom. Actually, one time I gave this talk, and somebody told me that there's a bigger layer underneath called meetings. I hope it's not the case in your company. We spend the majority of our time writing code. It's almost equivalent to developing software. It's almost equivalent. But then we also know that we are developers. We cannot trust each other. I even cannot trust myself. I can't trust my own code. So we should also do code review to one another. And this is the second layer. We also code review our peers and ourselves. And finally, we spend the smallest amount of time on writing specifications. So if you remember the first lesson, this is also something that is being done, usually at companies that are mature enough to have learned this lesson the hard way. But now, times are changing. AI is better at writing code than us. It's writing it faster, it's writing it better, and it's doing it at an amazing pace. So every time a new model comes out, every time a new declaration comes out, we learn that maybe it's actually better to give the model to write code. So what's going to happen to us? What are we going to do in the era of natural language coding where we just guide the AI? This pyramid that you are seeing is going to flip, and we are going to see what's going to happen on the right. Developers, as software engineers, we would deal more with guiding an AI on what to code. We would have to write specs. We would define the tasks that we want to get done. In fact, we will deal more with translating business to tech more than actually writing the bits and dealing with the code. So we would spend the majority of our time writing specifications. AI and the dev tools will write the code for us. And I'm not saying that it would be perfect. In fact, I'm saying that we would still need to do the same amount of code review that we've done before. We would still need to check our peers. We would still need to check our AI peers. We would need to check every code that goes into production because we know that code is not a stable animal. It's very, very risky. So we will do all of that. And finally, at the edge, maybe we will even code a little bit. Because we sent the task for the AI, it performs the task, executes it, gives us the code back, and maybe we want to make a small adjustment. We can do it, right? I'm not taking us away from the code. So this is the change of our skills, but I think the very interesting thing about this slide, the very interesting thing about these two pyramids, is at the core, it stays the same. Our profession stays the same. The job of the software engineer is to identify, analyze, and solve problems. In both pyramids, we are doing this, right? But in the pyramid of code-oriented development, we spend much more time writing code and slamming the keyboard. And in the pyramid on the right, with natural language coding, we can focus on solving the problem rather than actually coding it. We focus more on design, on specifications, on how to convert a business requirement into a technical product. This is the core of our work, and it's getting closer, if you may, to computer science, where we actually only think about how to solve problems efficiently, which is pretty amazing, and I think it gives us a glimpse into the essence of our profession in the future. Okay, so we will need to learn new skills. We will need to learn how to guide this AI. We will need to learn how to work with it. But our workflow will change as well. So an example from a previous change would be, okay, we moved to the cloud. We are now developing on the cloud. And now it's no longer, writing on your machine, building the code, etc. You need to change the way you work. And now you have GitHub Actions. You have the CI/CD. Everything is happening remotely. You need to make sure that you can view the logs remotely. It's no longer on your machine only. So how would the new workflow look like in the natural language coding era, where we are doing less of the coding and more of the guiding? So here's how you can imagine it. And here's where the world is going. And I think it's getting more and more evident with every product that is being released, with Copilot workspaces, with Devin. This is where we're headed. When you get a task, you start from specifications. You start from thinking, how do I solve this task? Now, this is not something that you must do on your own. AI can help you here as well, because there's no reason for AI not to know your code base, understand you, and guide you towards a better solution. So hand in hand with the AI, we can find the suitable solution that translates the business need into a technical product, in the most suitable way to our code base. Once we are done, and we've said, hey, we found a solution, this is what we think is the way to go, we can take this instruction, this specification, the manual for the requirement, and deliver it to an AI agent or an AI entity. This AI entity should be able to handle this task from end to end, meaning that it should be able to write new code, maybe search the existing code base, maybe find tests and run the tests that are relevant to this task. This entity should be able to do everything that we do, search online, send a message to another person on Slack. Everything that you do, it can do as well in order for it to perform truly great. And finally, and now we're getting to the small tip of the pyramid, this AI entity will bring back the code to you, and you will have to do the code review and the final steps to take it to production. Okay. So just to double down on these entities, which sound a bit vague, and it's like, okay, this sounds pretty great, but what are those AI agents? Do they even exist? Is this actually going to happen? So actually, AI agents are not a new concept. If you've been around in 2016 when reinforcement learning was booming, so AI agents were all the rage as well. Even OpenAI tried to train AI agents, but in another context, to try to give you the same feeling of an entity that you can actually talk to, and it delivers results to you as if it was another human. Not a new concept. But now that we have LLMs, and we have these large language models, we can set them up to run iteratively with some goals or tasks in mind. What am I talking about? So you are probably very familiar with the flow on the left, right? You give the model a requirement. Hey, I need you to write a paper about ABC. The model gives you a result. You say, that's not exactly what I meant. I need some changes. And then the model says, oh, forgive me, obviously. Here's the new version for your essay. You say, this is again not what I wanted. The model says, correct. Gives you another version, and then you get annoyed with it, start a new chat, or start completely from scratch. We are all familiar with this flow. With AI agents, what we can do is actually to automate this process, because why do we need all these green dots on the left? We can let the model talk with itself. So on the right, we tell the model, listen, you are an expert software engineer, or you are an expert writer, you are an expert whatever, and I want you to take the steps and talk with yourself and propagate this task that I'm giving you until you are done, and give me the result at the end. So for example, you would give the model a task like, hey, write this code, write a code for task X. The model writes some kind of definition of a function. Then it says, maybe I should look for bugs in this definition. Looks for bugs, tries to find them, tries to solve them, runs some tests, gets the feedback, tries to reiterate, etc., until it says, okay, I can't find any more problems. Here's the code you asked for. Pretty cool. But what do we need for this to work? So there are a few things that we need to define, and these are a few things that we will find in many future services, future products, anything that we will have to interact with AI agents. These are things that you will be familiar with. When we are talking about an AI agent that serves us, not only in the context of coding, but here on this slide, it's really suited to software development, there are 4 core concepts. There's the identity. What are you? Who are you? To this AI agent. So mostly it will be you are a senior Python developer, you are a senior Java developer, you are an expert DevOps. This is you. Kind of like the system prompt. We also have some context. So, a new developer joins our company, they need to start learning the context. What repositories do we have? What are our technical specifications? What third-party tools are we using? Maybe we are using a very specific version of React, so we need to make sure that we are familiar with the exact type of docs of this version of React. Then we also have tools, the third item. So us as humans, we have, we can search the web, we can go to Stack Overflow, we can consult another AI model, we can actually ask our colleague, we can look up the documentation, we can actually run some tests. We have multiple types of tools available to us that help us solve a problem efficiently. And finally, and I think maybe this is the most important part about AI agents, is the workflow. So I'll give an example about workflows. So maybe some of you are familiar with what I'm showing here. Anybody knows? It's a test-driven development. It's a myth. Nobody actually has seen it in practice, but it's a very beautiful theory. And because it's very difficult to program this way, we like to get started with code, we like to get started with a task in hand, but people have been saying for a while now that this is actually a great workflow, prevents many problems, makes sure that our code is documented and well-oriented, etc. And imagine that you have this AI agent that you can say, hey, in our company, this is how we work. When you are writing new pieces of code, this is how you work. You must first write a test, you make sure you fix it until it passes, and only then commit it back to me. So this agent that now we accepted into our lines in the company will work this way. And the best part is that it doesn't know that we don't even work this way. It's amazing. So in a matter, kind of if we look at it, actually test-driven development can just turn into development. This is just what we will do to develop code. Now I know that whenever I show this example, people say, yeah, this is nice, but in my company, it looks more like this. All right, we write some code, we test it, sometimes not. We're not really eager to test this code, and commit, push to production, and we'll face it when the clients complain. So, okay, it's a common practice, and the agent can work the same way, because we are defining the workflow. We can say, listen, when you're writing code, write the code, try to see if it works or not, then bring it back to me. I will deal with the last mile. You don't worry about it. So the workflow of these agents is completely up to us, which is pretty great. OK, so now that we've learned all of this about AI agents, and we've learned that we are going to spend much more of our time guiding them, it's a good time to stop and ask ourselves the question, is the end near for IDEs? Because I understand, and I think you can understand as well, why the IDE is perfectly suited for code-oriented development, right? We spend the majority of our time writing code. We need a tool that helps us with writing code, that knows the syntax, that understands the language, etc. But now we are focused on guiding AI, so is this the best tool for the job? Is this what we are going to use? I'm not sure. It's an open question. But I think that the tools that we are seeing released today are actually showing us that this will not be our interface with software. We are going to have a new interface, something that I still can't define, but I'm sure that we will experience new interfaces to build software. So this is just to reiterate the point with the pyramids. OK, so everything I'm telling you is not a dream. It's actually not so much futuristic. It's actually happening today. So I've mentioned Copilot workspaces. I've mentioned Devin. Me, myself, I'm in this field. All of these operations that you are seeing on the screen today are things that AI can handle pretty well today. These are things that you can already hand off. You can already outsource these tasks to an AI agent that will do a pretty accurate job. The only requirements are that you give it the right context, the right tools, and the right workflow. So to do all of those, you would still have to work a little bit, but then you would get this entire set of things for free from AI. I think the conclusion here, and to tie it all up, is that we are heading into an era with the ultimate developer experience, right? AI and these large language models are going to completely change how we work, the skills we have, how we communicate with each other and with the machines. And it's going to really flip what we are used to today. And in a way, it's going to solve many of the problems that I've shown you before, because if you think about these 5 lessons that I've shown you, the specifications that matter, right? Now, not only they matter, this is basically how we work, right? This is basically what we have to do. So it's no longer just a nice to have. It's actually what we do. If you think about the tooling problem, right? Now, it's no longer up to us to know all these tools, because for AI, it's very easy to have a long list of tools which it knows when to use and what to do with it. Pretty great. Coupling is no longer a bigger issue because this AI agent can talk to whatever he wants. It probably can talk between one another. Pretty great. Knowledge is not an issue for us. Maybe it is an issue for us, but it's not an issue for a system that can comprehend a huge amount of text. Pretty great. And continuous feedback will stay because I don't think it depends actually on what we work with. But a lot of the experience that we face as developers today, a lot of our developer experience is going to improve significantly, which is pretty awesome. And I want to finish with this quote from Thomas Domke, who's the CEO of GitHub. So he says, we are heading into a world where developers are more software architects and system designers. Right? So we are going to deal less and less with code and much more with solutions, with thinking about how are we going to solve something? How are we going to translate a business requirement into a technical software in the most efficient way? And this is coming from the person who's leading the largest organization using code today. So it's definitely in his interest that we will stay, we will continue to work with code, but this is what the largest company is pointing at today. And I think also if you go to their website and if you look at the materials that they are sharing recently, it's all about natural language coding. It's all about being able to guide an AI entity rather than work the keyboard, press the buttons, etc. So with this, I'll finish. Thank you so much. And I'll open Slido, I think. Okay, so isn't writing code essentially writing accurate specifications that are specific and unambiguous? Let me just zoom in a bit. Okay. For a computer to execute a task correctly. Right, so we can claim that code is actually specifications in a different language, right? Because we are writing the same things. We want to execute the same topic, but we define it much more clearly in a much more structured language, like Java, for example. Yes, we can claim that, but that's not how we speak. That's not the easiest way for us to express ideas. So imagine that you're contacting your friend, and you want to explain where do you want to meet tonight for drinks, but you have to do it with code. So it's pretty heavy. It's a pretty demanding language. And we want to be able to express ourselves much easier and to get the same results. And this is why we are dealing with English specifications or in any other language, rather than actually coding and developing the solution. Okay. Won't having an AI agent supervise another result end up in compounding the errors? So both agents are based on the same pre-trained LLM, basically both are wrong together. So it's a possibility, but I think where we are going is that we see products and teams that are developing solutions to face that, because you can have a different set of agents, and actually there are a few interesting articles about how putting a few agents together and telling them you are actually in a panel, in a conference, help each other understand better, actually fixes the results and makes us better. So there is the chance that errors will compound and they will just say, you are right, you are right, you are right, you are right, and will build for much longer, will compound the error. But this is where we also have to interfere as humans, because I'm not saying that, for example, you will give a task, forget all about it, and come back after 5 days and you have another application for Uber. But you want to be in the pilot seat, right? You want to make sure that what you're doing actually works. You will still be involved in the process. So it's not a break-free environment completely. Cool. And have you already tried giving this kind of specification to some AI agent in practice? How did it go? Was it able to generate a working project? Yes, it's working today. It's definitely out there. It definitely exists. There are multiple solutions out there. I would be, if come to me later, and I'll be happy to guide you to some websites. Okay, and is this an end to front-end multimodal models plus dribble behind for design? Is it? Yeah, so, okay. So where does front-end fit in all of this? So if you've seen OpenAI's declaration on GPT 4.0, you know that they are aiming for multimodality. They want these models to be able to see, because when we're doing front-end work, there are things that are important for us, pixel perfect and all of these expressions. So we want to be able to give a Figma file, for example, to this AI agent and tell it, hey, this is the website that I want. Please write code that suits this Figma file. So yes, this definitely will happen. In connection to, if I'm thinking about the previous question, I haven't seen this in practice yet. So this is very, very new. This is like the edge of the field right now. Okay. All right. Well, thank you so much again, and I hope you enjoy the rest of your day.